that I've been getting 80s and 90s in this class all year, so that means it's automatic for this reason. It's not at all. Not at all. I have seen a lot of years where kids get 80s and 90s, and then all of a sudden on the Regents, they're in the 70s because they just didn't prep. All right, they didn't prepare for it. A little laziness. Remember, you guys got your 80s and 90s in small chunks. This is all year now. Okay, this is all year. So I suggested some of the multiple choices last night. Is there anyone in particular? You had the work written out for you, and you have video solution. So if that wasn't good enough, that's what I'm here for now. So any of these that you wanted to talk through, these add up quickly when you get them wrong. 2 points apiece. You know, you get 5 wrong, there's 10 points off already, right? So if you want to do well in the 80s and 90s, you got to take your time on multiple choice. Anything we want to talk about? And look, I realize you guys have what? How many exams? 4 or 5 total? I get it. I'm not saying prioritize math number one, not at all, but have some kind of plan to study for. Via and then Zach, you're on deck.
6.
6, everyone. Let's take a look at 6 and talk through 6 together. Okay, yep, 6 is a tough one here. And this is why I think this Regent's complicated. Is you see this word right here, and you think it's like a trapezoid problem. I need to know properties of a trapezoid, and that's not the case. Okay, that's not the case at all. AE is 5.2. AC is, so all of AC is 11.7. CD is 10.5. And find the length of AB. All right, and they tell me, because it is a trapezoid, here's one of the properties, AB and CD are parallel. What type of angles are formed by parallel lines? Alternate interior, correct? So I know that these two are congruent. And if I go backwards, I know these two are congruent. See these two triangles? What do I know about them? Similar, because angle, right? Everyone see the two triangles that are similar, the top and the bottom? So if they're similar, that means their sides are in proportion. All right, their sides are in proportion. So I am taking this top triangle, AEB, and the bottom one, saying they're similar by angle, and now I got to match up their sides. Everyone ready? I'll go easy one first. X in the yellow matches up with what in the blue? What side does XAB match up with in the blue triangle? 10.5. So I'll start there. X over 10.5. Give me another side in the yellow, because I took X first from the yellow, so give me another side in the yellow triangle. 5.2 over, now you got to do a little work. It's going to be over CE. How can I find CE? Well, AC was 11.7 and AE is 5.2. So how can I find EC? Subtract them, and I should end up getting 6.5. And there's my proportion. So this had nothing to do with the trapezoid. It had everything to do with similar triangles and us figuring that out. And that is a huge topic today as well, similar triangles. We good here, Via? Okay, Zach, you are on deck. 20. Let's take a look at 20, everybody. And I have total faith in Via and Zach, but if you're going to ask a question, make sure it's because you tried it, not because you just scrolled through it right now and it looks tough. All right? Okay, write the equation of a circle. That's on your cold hard fact sheet. There's the circle equation. Okay, that's on your cold hard fact sheet. Anybody remember what numbers I plug in for H and K? Not in this problem, but in general, what h and k, those numbers are. That's the x and y coordinate of your center of the circle. And then r is not r squared, but r is your radius length. All right. Let's do half of it now. Let's do the left side. The center is 2, -4, h, k. 2, -4, h and k. So can you help me out? What should go inside the parentheses at least? X, y, h, and k. So what should go in the parentheses now? X -2. But now be careful. Now you're going to plug in a negative number. So what's going to happen here? Y +4. All right. So now we got to get to the r value. So let's see. Can I eliminate a couple? Yep. 3 and 4 are gone. So now it's just a matter of, do I pick 4 or 16, right? All right. Not sine, cosine, tangent. Tangent for a circle. Anybody remember that? That was a line that did what? How many spots? Once, right? Once. So let me throw. Also, I should. I'm going to put a grid up here right now, a graph. I just want to let you guys know this is an actual Regents exam. What you have in front of you, what you'll get in 2 weeks. You got a scrap sheet of graph paper on the back. Use it if you need it. Okay, because we don't hand out extra. All right, this is your scrap sheet of graph paper, so use it. All right, so if I graph this one, let's see, grid, just so you guys can see what the heck's going on here. 2, -4, x equals -2. So here's the center. Ooh, and this is, I'm telling you, this is a tough one. Anybody remember what this looks like? X equals -2 if I'm about to graph it. X equals. What type of line? Vertical line. Yep. So this is going to be x equal -1, -2. It's this line right here. So here's what's my circle looks like. You guys said what? The circle's only going to touch this line in how many spots? 1 spot, right? Okay, so here you go. Here's my circle. Right there. Okay, touches it in 1 spot. X equals -2. What are we looking for here? What were we missing in our equation? R radius squared. Can you guys find what the radius is for me? How long is that radius? 4 units, but do I plug in 4? They want you to, don't they? Look at the choices we have left over. One of them's 4. Pick me, pick me, pick me. It's tough, but it's got to be r squared, so 16 going in there. Okay, 16. Good question there. Woo. And that's just a multiple choice. But hey, it's the more it's reps. How do you get better at an instrument? Reps. How do you get better at sports? Reps. Same thing with math. Reps. Anything else before we go into today's stuff? So you remember yesterday was writing an equation of parallel and perpendicular lines and quadrilateral properties. Today, similar triangles. You'll see a ton of it. We just did one. Similar triangles and dilations of points and lines. All right, so let's do it. Here we go. Second day. Remind me if I forget, I may, what the assignment's going to be tonight, the suggested assignment. All right, here we go. Let's start it off. This is where I am, correct? This is where we left off yesterday. We're going to your study packet now. Study packet. We're done with the January 2020. We're going study packet. Go get set up. Let me get my numbers ready here. Already set up from yesterday. Perfect. All right, ready to roll. Here we go. Triangle CHR. I'm giving you a pair of angles are congruent. Can you mark them for me, please? Mark them on your diagram. HRDRDO, congruent. Okay, RD has a length of 4. RO is 6. OH, 4. What's the length of CD? How do I know these two triangles are similar? What's the main method again? What's the main method proving triangles similar? 18, start us off right. Main method? Angle, angle. I see the given pair, H and RDO. Where's the other pair for angle, angle, so I can prove to you that they are similar? 7, see another pair? Small triangle in the big one. Nothing's marked. What's that?
C and R. No,
What?
R.
What about it? You're correct. What about it?
It's both.
It's everyone see angle R is in both, so it's reflexive. It's angle, angle. Good. Now the sides are in a ratio, and this is a tough one. What sides match up, right? What sides match up so I can do my proportion here? I'm going to try to make this easy on you guys. Please listen to this, what I have to tell you. How to match up the sides if it's difficult. All right, I'm going to start with the small triangle. I'm going to start with 6. Everyone see 6 OR? Ooh, what side does that match up with in the big one? That's a tough one. It's tough for me to visualize, turn the triangle around. Here's what I'm going to tell you. Does everybody see that 6 is across from the congruent angle we marked? Everyone see that? So go to the large triangle. Go to angle H, which we marked. Name the side across from it. Don't tell me how long it is. Somebody name the side across from angle H in the big triangle. 6? CR. Now tell me how long it is. 11? How long is CR? X plus 4. Look at the congruent angles and the sides across. Everyone see what I did there? This is across from X plus 4, so it's got to match up with the congruent angle, which would be across from 6. See how I did that? Because we got to do it one more time. Go back to the small triangle. Name another side we know in the small triangle. 17. I already have 6. What's another length in the small one? Do I have one too, Zach? 17. Luke, where are you? Do I have one? I don't care what number you are. You're usually the one that tells me here. 9? What?
DR.
Which is 4, right? All right, now take a look. What angle is DR across from? Angle DOR, right? Can you guys figure out what angle DRO is congruent to in the big one? You already got these two done. Emma just told us angle R is congruent to angle R. So what? That only leaves one more angle for DOR to be congruent to, which is 15. DORN. No 15. No. Well, I need something in the big triangle. I need something in the big. Look, these two are equal. Angle R was congruent to itself. So this leaves DOR congruent to which one is not even accounted for in the big one? Which? Angle C. Now tell me the side across from angle C. Because they have to match up. The side across from DOR matches up with the side across from angle C, which is how long? It's 9?
10.
4 plus 6. Look across from the congruent angles. That'll tell you what sides match up every time, all right? Now go ahead, cross multiply, and let's finish this bad boy. What do we get on this one? 11? Right? Yes?
Yeah.
When two triangles are similar, the sides across from the congruent angles are the ones that match up. Because that was a tough one. Sometimes, we're going to do the next one now. It's not as tough to match them up. All right, sometimes it's not as tough. AC and DE are parallel. AD is 24, DB is 12, DE is 4. What side AC? All right, whoa, I'm not going to make this easy. Prove to me they're similar before I set up a proportion. How do I know those are similar? By, where's this? Where are those in there? Where's the angle in those two triangles? The big one and the small one. Emma, give me one.
B.
B's reflexive. Done. Give me it. Where's the other pair of angles then? Oh, we got to review a vocabulary term, don't we? Yep. Angle B is reflexive. Anybody see another pair that are congruent? Anybody remember what these were called? Angle A and BDE, if the lines are parallel? Not alternate interior, Scott? Those are corresponding. So everyone see angle? Now you have corresponding angles. All right. Set up the proportion for me. Let's do this. Give me a side in the small triangle. Oh, 6. What?
DEB.
A side?
DB.
12. Okay. That's all I needed. 12. What does 12 match up with in the big triangle? You cannot give me 24. That's not a full side. Give me full sides. 24 matches up with what side length in the big dog? 10?
36.
12 plus 24. Everyone see how we got 36? Got to have full sides, not partial. And then it's pretty easy from here, right? 12, now I'm going to pick 4, and 4 matches up with X. There we go. And remind me what we get here again. 12? We all right here? Getting a little more comfortable matching up sides. You're going to see it. All right. I've been mentioning this the entire time. There's also 2 other methods of proving triangles similar. All right, there's two other methods, which are also in your cold hard fact sheet. Side angle side, similarity. So the sides are in the same ratio and the angle in between is congruent. Anybody remember the other one? It's not listed up here, but angle, side, and if all 3 sides are in proportion. There you go. There's your 3 methods. All right, I'll let you guys look through these 4 choices right now. Which ones can I not prove similar? Basically, it doesn't fall within these 3. And I know they basically tell you 1 and 2 works. And what do we think here? Which one can't be proven similar because it doesn't fit one of those 3 methods? Let's hear 8. 3, yep. Reason being, those angles aren't in between, right? Those angles aren't in between. I got side, I got angle, and I got side again for the last one. You guys all good? All right, another one on your own here. I'm telling you the 2 triangles are similar, so give me the 4 numbers that fit that are in proportion. Okay, so for instance, number 1, if AD is 3, AB is 6, AE is 4, and AC is 12, does that make sense as far as the sides being in the same ratio? You guys decide. Okay, so basically, which 4 numbers give me the sides in the same ratio? Go ahead. 5, Jackson, when you're ready, which one fit there? 4, yep. 2 over 6 equals 5 over 15. We're done. Good work, everyone. All good? And I think that's it for, nope, I still got a couple more here, huh? All right, go ahead. You got the next 2. Go ahead, got the next 2 now. That first problem you're doing now, I am just going to cross off 3 and 4. There's no way it can be 3 and 4. Why not? Where's C and F? Remember, side angle side. Is C and F in between? No. So that, again, I don't care if the numbers are in the ratio or not. Can't be C congruent to F. That's not side angle side. So now it's a matter of 1 and 2. Which numbers are in the same ratio as 6 and 8, right? And then you guys figuring out for these the next 2 if these 2 triangles are similar or not. All right, how about the first one here? What numbers gave you similar triangles? Jackson, what do you got? Which numbers?
Wait for the top question.
Yep.
Number 1.
1, D, 9 over 12. Yep. 6 over 9 is the same as 8 over 12. All good? Questions there? And then what about the second one? Were these 2 triangles similar or not? 16? Similar? Yes, it were. Yep. By what method? Yep. Perfect. Side angle side similarity. Because if you did the proportion, 6 over 9 is the same ratio as 14 over 21. And the angles in between them. Good. Yes, Romeo.
The Regents, will we be able to write SAS or will we have to write outside angle side?
Nope. SAS, but you got to put the tilde there if we're talking similar triangles. Any abbreviations I've done with you over the years, like, right angle, CPCTC, that's all fair game. You can use that. But if you start making up your own, you're playing with fire because remember, I'm not allowed to grade your regions. Another teacher or teachers will be grading them. I'm not allowed to touch them at all. Okay? Other questions? All right, I just slipped this next one in there. It comes up every year, but I just want to make sure we're good with the vocabulary and how to figure it out. How many degrees of rotation will it be for carry it onto itself? Here's what carry it on. Again, carry a regular decagon onto itself. I start with the decagon and I end up with that same looking end decagon. It doesn't move. It's not tilted, right? I look with that same decagon. First, decagon. How many sides? 10 sides. Easiest way to do these problems, think about if you turned it all the way around, it would be the same decagon, right? And what do I mean by turning it all the way around? 360. Divided by the number of vertices it has. Well, if it has 10 sides, it has 10 vertices. So we're talking smallest amount I can rotate it, and it becomes the same decagon is 36 degrees. Don't expect that answer to be there, obviously, and it's not. Well, why not? Every 36 degrees, I get it back. So I could go 36. I could turn it twice, and that would be 72. I could turn it 3 times and still get it back, and that would be 108. See what I'm doing here? Every time you go 36 degrees, you're going to get that same looking decagon back. And I really gave it to you on this one. Sorry. So it ends up being how many degrees here eventually? 16 again? 252, yep. So if your original answer is not there, don't worry. Don't get nuts. Just keep adding that number again, and it'll eventually be there. All right, we good? All right, the second half of today is how to dilate a line. Dilations. Okay? Dilations. Real quick review, so we don't get nuts here right out of the gate. Quick review before we answer any of these questions. When I dilate a line, that doesn't mean it gets physically bigger or smaller. Lines can't do that. They go on forever. What happens? They either, say we're dilating around the origin, they either get closer or further away. Okay, so say I'm doing a scale factor of 2. Scale factor of 2. That just means this line segment's going to get twice as far away. Anybody remember, what do I know about the original and the dilated one? They are what to each other? Parallel. Yes, you dilate a line, they remain parallel to each other. All right, let's answer some of these now. So line L, 3x minus y equals 4. I'm going to dilate it by 2. Getting closer or further away from the origin? 2. Further away, but it remains parallel. Okay? I need you to solve this for y for me. Help me solve this for y so I figure out what the slope is. 10, start it off, Josh. How do I figure out, solve that for y? Yep. Okay, let's start by subtracting 3x. Okay, y is not by itself yet. I still need help. Josh did the first part, but it's still not by itself. Jackson, what else here? How do I get that negative out of there? -1 times y. So how do I get rid of the multiplication? Well, if I add, ready, take a look. If I add it over, it's gone, right? There's a -1 in front. So how do I get rid of that -1? Divide both sides by that -1. 3x minus 4. Everyone all right how we got there? Next step, I'm dilating it by 2. So it remains parallel. What is that? Jesus. Let's try that again. It remains parallel. So that's why it still starts off with 3x, my new line. Now the only thing that's going to change, -4. It got further away, right? It got further away by how much? 2. So I'm going to take 2 and multiply it by my y-intercept. What's my new y-intercept? -8. There you go. The lines remain parallel, and the new y-intercept I just multiply by whatever the scale factor is. All right, next. I'm going to take a triangle and dilate it by 3 now. When you dilate a triangle, do the angles change at all? No. So guess which 2 answers I'm eliminating right away?
1. Sorry.
3 and 4. Angles do not change measurements when you dilate. Just the sides. So which one up here is saying I am taking the original and multiplying by 3? Choice 2. Take the original, B and C, multiply by 3, you get B prime and C prime. Angles do not change. They remain congruent. Okay, next. I'm going to take a triangle and dilate it by 3. Which one's true? Can you eliminate 2 right away? Not choice 2, but 2 choices right away for me? If I'm dilating a triangle, which 2 definitely aren't going to work? Anybody confident in one of them that's not going to work? Emma? 4. We just said, right? Angles stay the same. And which other one? 3, yes. Because they're parallel, right? Slopes stay the same when they're parallel. So now it's a question of, is the perimeter 9 times or is the area 9 times? Ooh, we got to go back a couple units, don't we? Let's fill this in here. Oh, it's already filled out. Remember S1, remember doing this? Side ratio is the same as perimeters. Everyone remember that? Okay, so if the sides are getting 3 times bigger, how much should the perimeter get big as well? 3 times bigger, because they're always equal. But the area, it's a little different. Remember what we had to do for the sides? We had to do what to get to the area? Square them, yeah. I don't have time for that. So, if the sides are getting 3 times bigger, what about the area? 3 squared. The area is going to get 9 times bigger, right? Because the perimeters are, I'm getting there. Mr. Cronin. Hey, Heather. No, that's all right. Absolutely. Yep, bye-bye. Wait, is it me? Is it me? Is it me? What did I do? I didn't do anything today. Can I ask real quick if we had to choose one person in this room who was it was for to go in the main office? Who would our vote be for? Why Jackson? Was he a thug that I didn't know about? All right, that wouldn't have been my pick, but okay.
What would your
My pick? Hopefully you guys have thick skin. Probably be Carter. But actually,
It's kind of quiet.
Actually, this is a surprise pick here. Romeo, end of the period. You know Miss Coleman? She's one of the assistants. She needs to see it. I'm sure it's nothing bad, but she needs to see it. Yes. How about that twist right there, huh? How about that twist? All right. All right, let's get go. We got 6 minutes here, and I want to get through these last 2 with you. All right, here we go. Let's go. Next question. What's the ratio of BE to CD? Now, initially, when you guys see this and you're finding the ratios, you're like, oh boy, I need to figure out how long BE is and how long CD is and do a ratio. And the only way you're going to do that is distance formula, probably. And I don't think you want to pull out distance formula just yet in the review. So is there an easier way to figure out what the ratio of BE to CD is without finding their distances? And the answer is yes. What did I do with a triangle ABE? What did I do to triangle ABB? Is the image of ACD after A? Dilation. All right, ready? Is ABE getting bigger or smaller? Bigger. So I'm eliminating two answers right now. If ABE is getting bigger, I'm eliminating two. Which two? 1 and 3, because it's less than 1. Good. Now which one is it going to be? 3 or 2? I don't want to do distance either. But since I know they're similar, isn't AB in the same AB and what other side? AC in the same ratio? AB and AC, aren't they in the same? They should be in the same ratio as any other two sides. So why not do the two sides I can count instead? Everyone see where I'm going there? The two triangles are similar, so just do two pairs of sides, and that's the ratio for both triangles. So let's count it. How long's AC? AC should be 5. I think 4.5. I don't think it goes out to 5. Yeah, we got to go 4.5. And then how long's AB? 3. And that's not a choice, but we can put it in the calculator, right? 4.5 over 3. And 1.5, remember you got a math button on the left-hand side that turns it back into a fraction. 3/2. And again, if you did that at the beginning, how do I know it's 3/2 versus 2/3? Why am I eliminating 2/3 again? The triangle is getting bigger, and I need something bigger than 1. All right. I'm going to end it here, actually. We'll do this first one tomorrow, first thing in class, because I have to give you what I'm suggesting tonight. You can write it on the front of the packet, wherever you need.
Yeah, can you pick yourself a room? I would never pick yourself to go well. I haven't hopefully noticed something. I've been a pretty good boy this year. My finger, or was it broken 4 months ago? He just
Okay, here you go. All I'm suggesting tonight. Ready? Part 2s. That's it. The part 2s tonight. And I'm going to give you a warning. One of the part 2s is a construction. So if you plan on trying these out tonight, have your compass next to you, and you know where to locate all the constructions tonight on Google Classroom. So all I'm asking is the part 2s get done. And I will answer any of your questions tomorrow. You can go, Romeo, if you need to.